Hey, good morning, everyone. Welcome to 2021. Happy New Year. Looking forward to an exciting year. A lot different than last year, hopefully, but we'll find out soon enough. It's day one, so yeah, we don't have a lot of time down in it yet, but I'm optimistic. I have high hopes for 2021. Um, Welcome to season three of the Mass Transit video series. Season two ended up pretty good. We did an interlude a couple days ago. Might have been yesterday. I don't remember. Um, and I spent a lot of time yesterday kind of chatting with Drew Sellers. Everybody, knows Drew. Well, you might not know Drew. He was one of the co-founders of Mass Transit some 12, 13 years ago. I guess it's 2021, so now it's 13-ish years ago. And we're really talking about how we could do something in season three. Season two was very focused on the state machine. We covered everything. I mean, we went very deep into the state machine. And I wanted to, I've had this thought in the back of my mind of how we could do a series on building a real application, not just a demo app, not just, focused on a particular piece of functionality, but like how we could really build around mass transit in a company where we're building an application platform, we're building tools, we're building a solution. We're an SRE team, we own our operations, we want to have the kind of tools that we need. And we want to be able to make it so our developers can build and decompose large problems into something that we can manage and maintain and extend without having to constantly reinvent ourselves or deal with the complexities and the spaghetti code that eventually comes out of having 100 microservices in an application, which anybody who's watched any of my videos knows microservices. I hate the term. We're still doing service-oriented architecture. We're just now move all the complexity around. One of my favorite sayings of all time is complexity once created cannot be destroyed. You can just try to move it or manage it. So I try to keep complexity out of my systems. I keep the mass transit surface area very clean and simple so that all the complexity underneath of dealing with the transport and everything is taken care of. You don't have to worry about it. So with season three, I really wanted to focus on how we could build a complex architecture with mass transit. And when I say complex, I mean it more in the sophisticated sense versus the hard to understand. Trivial examples are great. They let you show concepts and they let you clearly communicate the capabilities of a framework or a library or a tool. But at some point, you have to take that back to your team and build an application with it. And so this season is really going to focus on some of the nuance. And I'm even going to go over some really subtle things that just, fit into taste or style or really make it to where you're taking mass transit and kind of tailoring it into your own for your application workspace and your own use case. So when I was looking for inspiration of this, I've talked a lot, and Conductor Conductor is like my white whale. It's something that I know makes things better, but I still have to figure out how to get it realistic. I brought some more of Conductor into the framework with version 7 by using it to support the job consumers. And again, job consumers are great, but they're the 1%. Most of the time, a consumer is going to work for you. Job consumers are really kind of taking that to another level. But Conductor has a discovery API. It uses a series of messages to discover services. And, I keep thinking of how that could get into being a larger part of an application architecture. And when I was talking with Drew about this, I was kind of like, this is one of those things that there are going to be 10 or 15 companies out there that grok this, love it, and are going to build an entire application stack for their business around it. And everybody else is just going to be using like the basics. I mean, this is the kind of thing, when I was working with Albert in California, we were talking about how we were out on the 5th floor and we were working on this project. And I mean, we built an entire application platform for distributed messaging around mass transit. And that's where a lot of the capabilities that were introduced in version 3 and version 4 came from, was that initial build of that application. And that really grew mass transit as far as capabilities. And those have been refined over the years. We've gotten better capabilities with the runtime. Open source and things like DI are just mainstream now, whereas back in the late 2000s, the number of people using dependency injection in their applications was very low. So we had to build a lot of the infrastructure and plumbing, and we built it around Top Shelf. We built it around our own sort of extensions and classes that sat around mass transit and sort of made it work, because there's mass transit, the framework, but then there's whatever substrate you have to create within your business and your application to make everything sort of cohesive. So when an engineer moves from one project to another or from one team to another, they really carry that knowledge with them and don't have to relearn, oh, this one's written using this library and this one's written using that library. It's really about building that ubiquitous understanding across the teams and across the engineers, so that they can build and just jump in and say, oh, I know this is where the message contracts are. I know this is where services are built. I know this is what I have to do. And it really accelerates the productivity of the teams and helps all across the board. So that's kind of a warm up for that. The other piece that jumped in is, and I want to share a link to the video, and I'll put it somewhere. And if I can figure out how to do cards in YouTube once this ends up on YouTube. But Jimmy Bogard, he's a friend of mine for several years. I've known him since some of the original alt.net conferences back in the 2007, 2008 eras. But Jimmy's a tremendous speaker. He's absolutely fantastic. The information he shares is great. And he gave a talk, I guess this was in 2020. I don't know when NDC was, but this talk on effective microservice and conversation patterns. This is, he gets into about 3/4 of the way in, and I want to say it's like right about here. And he starts his grill fryer dress drinks. His fast food restaurant thing really translates well, because if you think about it, it's a supply chain, it's a delivery chain. It's, I need some things, those things need other things, so on and so forth, and we're putting that together to drive that value and deliver, and ultimately a tray of food to the customer. And Jimmy does very good at doing this. I'll link the video in the description. But it's a great, and actually I can link it in the chat, but don't watch it now, watch it later, so I'll link it later.
Works really
I actually
well,
started playing the video. Awesome.
It does introduce
we'll stop that. But yes, hey Leonardo, welcome to the show. Albert's joined too, awesome. So, I was watching this, and it reminded me of kind of this idea and this thinking of how we could make systems communicate better. And so I really, helped me kind of tailor what I wanted to put into season 3. So I've created a new sample from scratch. I actually started this last night because, I had a rockin' New Year's Eve, so why not, right? Why not write code? And I wanted to kind of go over that a little bit, but the focus is going to be on how can we start from some of the basic messaging patterns around orchestration and choreography. There's a couple of different words that come into play here, but how can we really build that out and make something better to build our applications around? And I'm going to cover a myriad of mass transit technologies through this season. 2 of the key ones are going to be sagas and routing slips, but we're going to look at how we can take these atoms, these pieces of functionality within mass transit, and build them into our application structure in a way that allows us to effectively build efficient communications that are reliable and all the illities that come into play. So I'm going to jump into that. I'm going to jump into code, because obviously we're going to have some code. I did recently just push this up to GitHub, so if you're looking for a repo, the sample is called MassTransit/sample forkjoint. The name of the restaurant is called the forkjoint because you use a fork to eat and joint, but it's also kind of a play on the fact that one of the biggest challenges in distributed systems is the fork join problem. We have this, we get an order, someone puts in an order, and we have to fork that order out to a number of different services to get burgers made, to get burgers dressed, to get fries made, to get drinks poured, to get everything combined and put onto this tray to deliver to the customer. So, I thought it was a fun name. I think I'm a dork and, can come up with this crazy stuff. So it works pretty well. The code for the first branch that I put together is up on GitHub. I'll have a link to that in the description as well. But it will definitely, the code should be big enough on the screen, so hopefully we'll be fine. But once this is over, and I'll be doing commits based on the chapters as well, like I did last time. So when we have episode 2, I'll do a commit for that to kind of make it so you can jump to the different commit points to look at the way the code did at the end of a particular episode. So that seemed to work pretty well, and feedback was that that was useful. So what I have here, jumping into this, is I have a simple ASP.NET application, and I've reduced it down. I'm going to tease this out and break it out later, but for now I've put it in a simple single project called forkjoint.api. I've stripped this down to where I have a single controller called the order controller. And the order controller looks like many of the other samples. It uses a request client to submit an order to some consumer in response to an HTTP endpoint being hit. It's pretty simple. I mean, we'll go ahead and run it because why not? Our submit order model is very, very simple. If we run this, to run the project, I do have a Docker compose in there. And if you look, you can just spin up the RabbitMQ part. This service can be run with F5 or it can be run in the Docker container. It'll run either way. There's code within the startup because I want a good developer experience on this. So there's code within the startup to detect if it's running in a container, and if it is, it'll use the RabbitMQ host name to connect to RabbitMQ. If it's on localhost, it'll use, if it's running F5, not in a container, it'll just use localhost, which the Docker compose has mapped to be my localhost RabbitMQ ports. So I'm just going to F5 this up since RabbitMQ is running. That way I have nice debugger experience with all my backing services running in Docker. Yeah, so all I have right now is the HTTP post for the order. The HTTP post, it's very simple right now. I haven't put a lot of functionality into it yet. All it does is take the order ID and submit the order and return a couple of responses. If I try it out, I can execute. If I go over to my debug window, I can see that I created some messages, I declared some queues, I sent a submit order message to the submit order endpoint, fork join contracts submit order, so I published the order. No, I didn't do that. No, I did a send. Oh, I have to look at that. Right, create said transport. Yeah, there's the response. I sent the response back, and we received on submit order, and we received on that. Okay, great. So that's all up. Now, if I remember right, it should have, let me look here. Okay, yeah, so we declared the exchange, we called up. Yeah, everything's great there. Awesome. So now one of the things that I want to look at is, we put this structure together, but I kind of want to look at request response and what that is. And so to do that, I've put together a sequence diagram of request response. So if you've never used web sequence diagrams, there's like 8 of them. I use whichever one I remember the dialogue for. This one isn't as pretty, but it's great. It works. So when we compare what MassTransit is doing with request response versus what, say, HTTP is doing, when we use an HTTP client and we send a request, HTTP is a transfer protocol. So all we are doing is transferring messages across a socket connection to a server that is using that same connection to respond back to the client. So we're calling an HTTP endpoint, and while that connection is hot, we're doing some processing and we're responding back to the client. Now, the whole point of using durable messaging and breaking things up is to eliminate that temporal coupling and to add durability and other capabilities into the system. So down below, we can see what happens when MassTransit is using the request client to do a GET response. So MassTransit, the client actually sends the message to the service queue because it doesn't commute directly with the endpoint. It says, okay, queue, here is my request. I'm going to put that into your service queue. The service queue broker is then going to deliver that request to the consumer on the service endpoint, which is then going to process that request. It's going to look at the headers of that message, including request ID and response address. And using that response address, it's going to deliver a response to that queue. It doesn't know what the client is, and it doesn't care. It's established that when I get a message, if it has a response address, my outgoing messages that I respond with are going to go to that queue. I don't care who gets them. The request client is then smart enough to then connect a consumer to that queue to say, hey, when you get a message of my type response, and the request ID correlates to the one that I've given you, give that message to me so that I can complete that await statement. So that communication and that back and forth is all managed within a simple await call within the .NET runtime. So when you create an async method, and I have another document here that I was going to share. There's an article in the dev blogs Microsoft that talks about how async methods work in C#. And if you look down into this, and this like gets into the super geeky aspects of it, but the first thing that it covers is that task of T is essentially a promise. Promises and futures really kind of redefine the way we were able to walk away from continuation passing and use this new async and await syntax that was brought in. I think it was C#5, maybe? I don't know. Oh yeah, there it is. C#5 introduced async methods. So task really gave us this future promise type model where all we had to, and we could pass these around. With a continuation passing, we had no real way to share, the future value of some expression. And now with task, we can do that. And one of the mental model shifts that I'm going to push through in this season is how to take that concept of a future of T or task of T and distribute that across your applications and use that to do, whether it's orchestration or choreography across your systems. So you can read this article. Again, I will link it in the comments, but if you look at the internals, it's all still continuation passing. It's just doing it inside of a state machine that .NET compiler, that the C# compiler builds to support the async and await syntax. So, it's really just you have a bag of state and you keep passing that down the road and continue with based on how those asynchronous methods complete. And what you'll find is if you read this article and you start to look at some of the tools that we're going to create using MassTransit, you'll see the parallels of how we're really just passing state around, whether that state is stored in a Saga repository or that state is stored in a dictionary on the wire with the message. We're able to use the network as state because we're using durable message, or we're able to use a database to store that as well. So that's some of the things that we're going to talk about in this season of how we can do some choreography to build these services to make them talk together. So that's a good article. I'm going to link that one in the comments when I get done. The code that's in place so far, like I said, I have a simple consumer that I'm running in here. That's the submit order consumer. All it does is respond with an order submission accepted, which again, as we just went through on that sequence diagram, that's going to take and look at the response address, copy that into the outbound message along with the request ID so that the request client can complete. Now this is set up, like I said, with a Docker build and everything so that it can run, and you can actually run this in the container. So if I stop this here and I go out to my container, go out to the console, and it'll stop RabbitMQ. But if I do a Docker compose up -- build, we will build the .NET code. You can see it's trying to connect to RabbitMQ instead of localhost. Once RabbitMQ is up, it's going to declare all the exchanges, declare all the contracts set up there. And if I go back to my website and refresh it, it's still there. Same ports, same everything. So it makes the debugging experience really clean. I'm able to see the log in here. If I go in here to post and I say try it out and I say execute, I can see all the logs. I can see I'm declaring exchange names. I'm doing send. I'm binding to the source queue. I got a consumer. I declare the exchange name, forkjoint contract, submit order. And it looks like in this case, I'm actually publishing the request, which is interesting because I shouldn't be, but I will figure that out at some point. I don't want to make that the focus of this episode. But it sends that out and it gets the response. Now, one of the messages that you'll see in here is the send of submit order up. This is a discovery capability of Conductor. So Conductors has the concept of a service endpoint. And when I put my services inside of a service instance, or when I call configure endpoints within a service instance, what I'm doing is I'm actually configuring a conductor to actually manage those endpoints. And what that allows me to do is do discovery. So if my request client wants to connect to a service that supports message type of T, it sends a link message out, which it isn't doing right now, which concerns me because it should be. It sends a link message out, which should connect to the control endpoint of the service endpoint, ask it, what the address of the service is, and that's done via a publish, so that it can then send directly to that service. And so if I go out to RabbitMQ and look at what the local broker looks like, I'm just going to log in as guest because that's who I am. I can look at the queues and I can see I have submit order and I have submit order control, which is an expiring queue. This only exists if the service is up and running. So if the service isn't running, I won't be able to get that address. Because again, request response, I'm expecting a response. It wants a response for that conversation. And you can see that I went out here and it creates exchanges for the link, unlink, and up commands. Now these look different. So when I'm, by default, and here I'm going to show this because I'm going to go out here and I'm going to stop this and just bring up RabbitMQ and kind of bring this up in the debugger so I can show you the differences. One of the things people ask a lot about is how do I change the name of the exchanges for messages in RabbitMQ? And the defaults are sort of out of the box defaults. They work as they work. And they fit and they work across all the different brokers. But sometimes people want to rename things, or they don't want the messages to have a certain format. And so what I've decided for this application is that I don't want the conductor endpoints to have crazy names. So I'm going to take this out and show what it looks like if I just F5 it. If I take out this custom entity name formatter that I created, you're going to see some really long exchange name gets created in here. Well, we got to let that run. But now you can see I've got this MassTransit contracts, conductor, link, unlink, up. I've got all these weird messages that are kind of out of band of the ones that I created before. And they bind to the same place. If I actually click on these, you'll see they're bound to submit order control, which supports both of those. Because again, they're temporary. All those other links are broken because those are temporary queues. So I don't like that long name. I find it kind of annoying. So what I did is I actually created with my own custom entity name formatter. And I put this in my contracts assembly because I want to be able to share this with, so that everybody names things correctly. And so I just created an extension method that takes the existing message topology and creates my own custom entity name formatter. And what I did is I said, hey, if the message type is generic and closes any of these types, link, up, down, or unlink, which are the conductor message types, I want to take and call the original entity name formatter, get the format name of the message type that's in that generic type, and then just put a suffix on the end of that of the type that it is, whether it's link, up, down, or unlink. And you can see when you look back at the exchange, that looks a lot cleaner. You have your submit order, and then you have your conductor messages right after it. So I made that change because I didn't like the way that looked in the broker, and I wanted to be able to manage this a little cleaner. So that's one thing that a lot of people ask about is how do I customize those names? And this is something that I want to do because I want to be able to manage this. I'm not going to change the default behavior of MassTransit, which is really easy for me to do because it may break people, and it's customizable, and it's an extension point that I can use to kind of ingest MassTransit as part of my application framework and not have to jump all into it. So now if I go out and I make that change, I think I put that back. Yeah. When I hit F5, we get that. That's great. And now if I go back, I can delete these because there isn't going to be anything connected to them. If I refresh this, I just want to delete these because these are no longer there. So I'm just going to delete it. I'm going to delete this one because I don't need it. And I'm going to delete this one because I don't need it. I'm going to clean up my broker. I'm going to get back to where I have these very simple commands, and that allows me to do service discovery on my service. The queues are still there. Control is there. It's going to expire. Submit order is durable because I want the orders submitted to be kept around. But that's about the extent of that. One other thing that I wanted to go on this and kind of cover just some highlights of what we're going to go into. The request ID and the response address are set up. And there was one other thing that I wanted to show about that in here. Oh, I write a log message out when I get the message. So let me see here. And this is taking advantage of a new .NET 5 feature called module initializers. I don't like to go and remember what my correlation ID is for every message out there and hard code that anywhere. So if I look here and I have this order ID and I hit execute, it's going to go off and it's going to run that message and I get the order ID back. When I go and look in my log, I see an order submission received message here. And you'll notice I'm writing out 2 identifiers. And those identifiers are exactly the same, which is great because I want them to be the same. When I go into my consumer and look at my submit order consumer, I'm writing out the order ID and the correlation ID. Now the correlation ID is a header on the message, and it can be used for actual correlation to things like sagas. So we have an interface called correlated by GUID that you can use to create your own correlation expressions, but a lot of people just don't like to use that. It has to have the name correlation ID and it conflicts with the header name. People get confused. So a lot of times they want to put their business identifier name in there. Question in the chat, is this Serolog? Yes, it is Serolog. So what I can do is in my contracts assembly, I've specified not just the custom entity name formatter, but within the submit order type, which I'm using interfaces. In my last sample, I did records just to show you could, but I went back to interfaces because I like my initializers. I like to enforce that. I put a module initializer that sets the submit order message. It goes to the global topology and says, hey, for the submit order message, the correlation ID is order ID. If I take this out and I run this again, once this comes up, it should bring up another little Swagger window. I come in here and I say post order, I say try it out, and I say execute. Now when I look at that log, I can see that the order submission received, but correlation ID is null because the correlation ID by default, if it sees a property in the message named correlation ID, command ID, or event ID, it will auto copy it, but otherwise it doesn't know. It can't just go pick a property that's a GUID and say, hey, this is my correlation ID. That would create havoc and probably irritate people to no end. But by having this initializer right inside the interface, it makes it very easy to share with the rest of the application that, hey, if I build a state machine and I'm going to get the submit order message, or more importantly, if I'm going to get like the order submission exception message, I don't have to define the correlation for that. I know it's going to be that order ID. So I don't have to repeat that information across all my application. So again, that's one of those things that falls into developer friendliness, but as I'm consuming this as an application builder, I want to take advantage of those cool capabilities. So request response is really kind of one of the easiest things to talk about. But again, let's go back to that web sequence diagram because I want to go back to what's being done here. When I do a request response with MassTransit, I'm sending a message to a queue and I'm waiting for a message to be received on a queue. I'm essentially, within the request client, returning a task of T that is a future to say, hey, in the future, you're either going to get a response or that task is going to throw an exception. And the plumbing underneath MassTransit is doing all the work to say, okay, well, I've connected to the queue, I've created a temporary consumer, it's going to receive that message, correlate it back to the request ID, and all is going to be great. If a fault is produced and I get a fault instead, I'm going to convert that into an exception and complete the task with an exception, because I'm going to blow up and it's a bad time. And on the consumer side that's actually handling the request, it's just consuming a message. It knows the input type. And if there's a response address, it knows how to write a response back. It could even check and say, hey, if there isn't a response address, I have nobody to tell anybody thing to. And I could go into that consumer and say, hey, you know what? I don't really need to do this, but if context.responseAddress is not equal to null, then I'm going to respond. I'm going to say, hey, somebody asked, I'm going to tell them because they asked and I would like to give them this information back. This allows me to use this same consumer with both a send or a request client. If the request client isn't used and they're just sending to the address to submit the order and they're basically relying on durable messaging to process the order, the consumer doesn't even have to respond because there's nothing to say. The other thing that got me thinking on this is, This is a two-party conversation. I have the client, and I have the request client, and I have the consumer. But what happens when we want to introduce a second consumer? And I take this back to the fast food example. So if I need to, say, order a hamburger, and that hamburger should have lettuce, pickles, onions, ketchup, mustard, all the things that you get on a Big Mac or a Big Mick, so to speak. Those are things that, it's a process of building a hamburger. Typically the cold bar with the dressings. Yes, hamburger. What's more American than hamburger? And I am American, so. Typically you have the grill guy who's making, the grill person who is making, cooking up all the burgers, getting them all ready, and they're putting them onto some sort of intermediary tray that's going to say, okay, now they're ready to dress. The dressing person usually has the dressing ready. They got the bun laid out. They've got the lettuce. They got the tomatoes. They got the pickles. They got all the good stuff set up. And that burger is going to make its way into. So, the dressing guy can get ready because he kind of has a future of, hey, I'm going to complete. Once this future completes and I get that hamburger patty cooked the way they like it, whether it's medium rare or medium well, I'm going to take and put that into this ready to go stack of, buns and dressing stuff. What is it? They're not really condiments because there's more than ketchup. But anyway, the fixins. Let's just call them the fixins, shall we? Let's call them the fixins. So they're going to put those into there. They're going to slap that patty in there. They're going to close it up, wrap it, and put it on the tray. Now, at first I thought, I could really get kind of janky and just change the response address to be the next consumer in the line, and with the response type being burger, But then it started to get weird, and it's like, how do you trick the infrastructure to handle it? And it turns out that simple request response can get much more complex with a feature that MassTransit has called Courier. So Courier is the routing slip implementation. It allows you to specify activities, and activities act like consumers. They have a set of arguments that they take in, which is your input message type, basically. And they can output any number of types to a working space or a memory. And I'm just going to tease that a bit because I want to save that for episode 2. Because we're going to bring another participant into the conversation with this request. We're going to start building out the restaurant. We're going to take the order and we're going to start putting together, okay, well, let's get the burger bar built because we need to be able to handle the hamburger problem. So that's going to come up in episode 2. So far, we've just covered, how async await works, how HTTP compares to sending a message to a queue and getting a response, how the underlying plumbing makes it work through the response address and just dealing with type-based routing of messages, and taking that mental model and thinking about it. But we're going to continue to keep that mindset, as someone just pointed out in the chat, when we're building an enterprise level app and a production level app, is how do we keep this so that developers can maintain it? And how can we use third-party projects like MassTransit to give us the benefits without, but yet tailor it to what we need to fit within our business. And we're going to continue exploring this fast food model throughout the entire season to really build out a complete application. So I'm going to link the video that Jimmy posted, the effective microservice communication. It's a great one to watch. He covers a lot of the things, and he's talked about the fast food example for years now, it seems like, and it always resonates because people can understand it, and it isn't as super complex as like an ERP supply chain domain where we're talking about order management systems, talking to inventory management systems, talking to warehouse management systems, but all the same principles apply, and we could ultimately build an entire supply chain system starting with just the primitives of a grill, a dressing stand, a soda fountain, a fryer, So stay tuned this season. It's going to be a lot of fun. I will make sure that the code for this sample is up on GitHub. In fact, it already is. And in the next episode, we're going to bring that second consumer in and kind of make the shift towards how we can do some simple choreography by using the routing slip to chain those activities together of making a hamburger. So thanks for joining today. The next episode might come out today. You never know. I'm 2 weeks into a vacation that and the weather is crap outside, so I'm not going anywhere. you know, I don't want to watch football or parades. So really, this is kind of what I'm trying to do today. So we'll see. I might have more today. If not, I might do some through the weekend, or who knows. We'll see. But stay tuned. Thanks for joining, and we'll catch you next time. Bye.